Next set of instruction is dealing with copying data values, and the ways to do this. Of course, there is a move instruction. There is exchange instruction. So if we illustrate the move instruction, would use two operands, of course, like this, with a comma, and the idea is to move this way, right? Exchange would do both. It would move this way and this way, essentially swap the values. The only limitation of exchange is that it cannot exchange any immediate values, and it can also work with two memory locations. But if one of the operands is in memory, that's okay. And these are obsolete instructions that allow to deal with sign extension or zero extension. And so we have references in this handout for these two instructions, but they became obsolete and now replaced by move. There is move sign extension, MOVSX, and there is also move zero extension. So we'll see examples of these in our presentation. Okay, so the move instruction is, we've seen this a lot already. So these are just different formats. So we can use immediate values. And by the way, BX register as index here, I would prefer to use EBX because BX would be mostly used on a 16-bit platform. But nevertheless, all of these three samples or line of instructions demonstrate how you would move an immediate value to register, to memory, and to memory combined with the register value, memory indirect. So anytime a register is involved in computing a memory address, we call it memory indirect type of access to the actual memory location. So register moves, of course, we can, instead of using immediate values, we can use the register. Direct memory moves like this, basically from memory to register. Of course, you cannot move from memory to memory. That's restricted. That's not available. Also, indirect memory moves. Basically, it's the opposite of what we did earlier in these examples. And segment register moves are available in 16-bit unprotected mode. We are not using segment registers because in protected memory mode, in 32-bit, I should say, protected memory mode, the segment memory registers become segment control registers, which allow memory protection and assignment of memory attributes such as executable memory, read-only memory, read and write memory, so these are not accessible to application programs and reserved to be used by the operating system. They also provide mapping to physical, from virtual memory to physical memory combined with virtual memory addresses. So this is just a summary of what we had in the previous slide. So let's talk a little bit about exchange instruction. So this is for exchanging integer values, and available formats are that we can exchange register with register, register with memory, and memory with register, right? So these are available formats. We cannot exchange two memory locations. We have to do this in steps. Okay, so that's of course the restriction. So everything is similar to using move instruction, except two memories cannot be exchanged. And immediate operands are also not allowed. So you cannot exchange 5 with the register because that's an immediate value. So these are examples of using exchange, and they're extremely similar to move instruction. So, but in the case of exchange, both are updated. All right. So if we need to exchange two values in memory, we can use a move instruction to load the first value into the register. Then we can exchange this register with the second value like this, and finally we can move the first value to the first memory location. So just at least 3 instructions are required to do something like this. Byte swap is convenient to convert between big Indian and little Indian forms. Okay, so these are so because it's so important to be able to convert between these two memory type of storages. There is a dedicated instruction to this, and so Byte swap simply just says, give me your value like this register EAX, and it will, you can see how it will rotate all bytes to convert from little Indian to big Indian form. Now, I already told you that these instructions are kind of obsolete. They are being replaced by moves with sign extend and move with zero extend. I keep them here just for the reference, because those are more historical commands. They're rarely used today, and so I'm just going to skip over these examples using sign extension. So these are more example of sign extension. In case so the better version of sign extension operation on our platform x86 is to use move sign extension command. All right. So for instance, we can set register to contain some value. Let's maybe use this example right here. So we can move into register BX, which is a 16-bit register, a value of minus 123. Okay, whatever. And then we want to extend this. We decided that sometime later on. Okay, we decided that we want to move from BX to EBX, right? So we want to sign extend into entire EBX from 16-bit into 32-bit, and we want to be able to maintain the sign, maintain the 2's complement encoding of negative and positive numbers. So move like this will not compile, because move wants the same size operands on both sides. I'm not even going to attempt to compile this or build this with this situation. So we need to use MOVSX, which is move with sign extension. So move with sign extension will do this, and now register EBX will contain value minus 123. So this is sign extension. And likewise, you can go from for instance, we can use even a smaller register from BL to EBX, or even other registers. It's extremely convenient type of instruction, and just remember that this what you would use to deal with preservation of a sign when converting from smaller data type to a larger data type. And of course, let's just build this once to make sure that the syntax is okay and everything is okay. So this is your example of sign extension. If you want to move without sign extension using the zero extension, the corresponding command is MOVZX, right, which is corresponding to zero extension. So basically, we want to move from smaller to larger registers or memory with with treating all numbers as unsigned 0 or positive only values. And another instruction that kind of falls into the category of data copying is this the translation instruction. Allows to extract values from a table of bytes using an index. This is very, very special instruction, and of course, there's an example of it, but I'll leave it to you as a self-learning exercise. So I'm not planning to use this instruction in our laboratory exercises. It's just for your information that this is yet another part of data transfer family of instructions.